The Fibonacci sequence is 1, 1, 2, 3, 5, 8, where each term after the first two is the sum of the previous two terms. What is the remainder when the 2013th term in the sequence is divided by 7? Well, let's just list out some of the Fibonacci sequence. We already have some listed, but I'm going to list a little more. And I'm going to see if we can find a pattern. Alright? When we're dealing with remainders, there's usually a pattern, and because when you divide by 7, in this case, this is 7, the remainders can only be 0, 1, 2, 3, 4, 5, and 6. Okay? And then they cycle over again. So when you're dealing with something like the 2000th term of a remainder, there's probably a pattern involved. It's a good hunch. So I'm going to list out some of the Fibonacci sequence, and then we'll look at what the remainders are. So let's see, 13, and then we have 21, and then we have 34, and then we have 55, and then we would have what, 89? Okay, that's enough for now. If we need more, we'll do more. Okay, so let's look at the remainders of each of those terms when they're divided by 7. So you divide 1 by 7, it's basically 0 sevens and 1 1. So the remainder is 1. Alright, remainder here is 1. So until we get to something bigger than 7, the remainder is just going to be the number that we're dividing by. So this is the remainder of 2, remainder of 3, remainder of 5, and finally we get to get 8. The remainder there is 1. Okay. Now 13, divide that by 7, we get a remainder of 6. So we have 1, 7, and a 6 make 13. Okay. 21, divide that by 7, it goes evenly in there 3 times, so we have a remainder of 0. Okay. And then we can go on to 34. Divide that by 6. Let's see, that's going to be, we can go in at 28 times with a remainder of 6. So 6. So you might notice here, this matches the Fibonacci sequence, but the remainders are also a Fibonacci sequence. Do you see that? So this 1 plus 5 is 6. And then the 1 plus 6 is 7, but when we divide by 7, the 7 becomes a 0. So, so we can put a 0. And then 6 plus 0 is 6. 0 plus 6, we'll get a remainder again of 6. Here we'll have 12, which is 1, 7, and a 5, so we have a remainder of 5. Okay, so it's almost like we get a Fibonacci sequence unless unless they add to something greater than 7, and then we have to take the remainder of that to get the remainder, right? So so we can come up with the Fibonacci pattern. So let's keep going. So there's 6 and 5 is 11. That's a 7 and 4, so a remainder of 4. And this kind of makes sense too. That you figure that the remainders of these are something between 0 and 6. And so, like for example, 13 has a remainder of 6. 21 has a remainder of 0. And when we add 13 and 21 together, the remainder is going to be 6, right? So, so it makes sense that the remainders are sort of a pseudo Fibonacci series, which resets itself once it gets bigger than 7 or bigger than 6. Okay, so all right, so we have 9. That's a remainder of 2. 6, 8 has a remainder of 1. 6 and 1 is 7, so that's a remainder of 0. And then we'd have 1, and then we'd have 1, and we'd have 2, and you can see we're going to start over again. So starting here, let me put a line down here, our Fibonacci sequence is starting over again. So we have a pattern that repeats itself. It's a pretty long pattern here, but this whole pattern right along in here just repeats itself over and over again. And there's how many terms in that pattern? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 terms in our pattern. Alright? So we want to figure out what the 2013th term is, right? That's our goal. So we have to figure out how many times this pattern of 16 repeats itself, and then how many more. So if we divide 16 into 2013, okay, that goes in once, 16, 41, okay, we can take that times 2, that gives us 32, and so that's 9, drop the 3, let's see, 5 times that is 80, right? Or is it? Hang on, 5 times, yeah, that's 80. Okay, and then 13. And then, so we have a remainder of 13. Okay? So what this tells us is that we're going to go through this pattern 125 times and 13 more to get to the 2013th term. Okay? So we need to figure out what the 13th term in this pattern is, and then we'll know what the 2013th term in this pattern is. So let's count out, well, I guess it's just so this is the 16th, 15th, 14th, 13th, so this has to be the 13th number in the pattern, right? I could count it the other way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay? So the answer to this question is that the remainder, when the 2013th term in the sequence is divided by 7, is 2.